So I'm Julien. Thanks, Michael, for inviting me to be part of this, and to the organizers who organized this encounter between science, art, and us. I work at the Natural History Museum, as you can see. It's like kind of a cabinet of curiosities with a lot of patterns, shapes you can see, which is a good thing for me because by training I'm a mathematician and I work in a Natural History Museum. So you can find mathematics everywhere, in every room, in every exhibit. So that's really nice to say. I mean, right from a very young age, I was fascinated and interested by interesting objects. And as a matter of fact, in museums, and not only natural history museums, but museums that can be art museums or other museums, history museums, they showcase interesting objects. And objects you see there, it's a really good thing because objects you see there, they bring some kind of story. So you could put like a bird and just have the material of the bird there, but it only makes sense and it gives a story when you see there's a bird and as a bird which brings its story and its story inside the big story of nature. And that's something which is really important, that these objects you see in museums, they transport emotions and they transport these stories. And when we go to these museums, we can attach to it and it will transform us in some sense. And this is very similar to objects you have in a science museum or objects you have in an art museum. Let me give an example. What I choose here is a slice of a meteorite. So this is in our museum, and when you look at it, you have a meteorite. It's iron nickel meteorite, so the material is clear. But you look close at it, and you see these parallel lines in one direction and then in the other direction. And this object itself, it tells the story of the formation of the solar system. So when the solar system formed, there was big clouds of gas and dust, and these particles stick together to grow bigger and bigger. And then it was it's the wind, the biggest one takes it all, and it gets really big, like hundreds of kilometers in diameter. And you can ask the question, so we have this object here in the museum, so at some point there have to be a big collision of two big objects, liberating part of the core, with the metallic core of this asteroid, and it had to drop to the Earth, and it had to be found, and it had to be a scientist who really knows the value of it, and he had to put it in a museum. So this whole story comes with it, and holding such an object in your hand, it makes something with you. It changes you somehow emotionally. And I think these emotions are very closely linked to what we perceive as beautiful. Beauty is really much related to emotions, I think, and you can't distinguish them. Here's another example, just because you put it in your exposition. We will see it afterwards probably. So this is a pyrid, which when it grows has often, not always, but often the shape of cubes. Very beautiful. But you don't have to go to museums. I tend to say that nature is the biggest artist out there. You can just wait for spring and then you go to the forest. And when you do that, and you are lucky enough, you will find a leaf. And if you're even luckier, you take that leaf and the sun is shining and you hold it in the sun. So observe this leaf. It has parallel lines. There's some structure in it, parallel lines, and I don't know if you see it from your perspective, but you go closer, you will see that in between these parallel lines is a web of veins going around, and when you hold it in the light, it's truly beautiful. Then you stay in the forest, you wait a little bit until autumn, and your leaf will dry out. It will change color, And when it dries out, in fact, it doesn't dry uniformly. So it will dry out at the boundary first, and also not at the same speed where you have the veins. So what will happen is that it will start wobbling around the boundary, and this process will turn your leaf into little hyperbolic spaces. Okay, so knowing this story and this process makes this leaf very, very beautiful. So next time you go to the forest, you have to know that there are tens of thousands of little hyperbolic spaces around you. So this is truly amazing to put this importance to a leaf. And I think that this ability of us, of humans, or perhaps other animals can do it, I don't know, but we have the ability to be able to intentionally focus on something. Also, we can also focus unintentionally, but we can take the decision to stop, to look at the ground and to take a leave, which is nonsense. You don't need it to eat and you don't need it to survive, but you can look at it. And I think that this ability to intentionally focus is really much related, and to discover these curiosities in this leaf is part of the beginning of the story of science, because you can observe and you just look at it and start to be amazed and be curious and ask questions. So this is really important in this story, I think. This too, truly amazing. So we wait a little bit longer until spring, and then I found this thing. So this tells a story. You see the seed of an oak tree, and this seed was lying in the forest, and it has the right conditions, the right nutritions in the soil, the water, that it grew roots, and then it grew a little plant. And by looking at this, you see this whole story of the evolution of this plant, this structure it has. For the little story, I took this and I put it in a little in the ground at my house, and it grows bigger and bigger. I can't pull it out anymore. Yeah, and then you were talking in the morning. You were talking about bubbles to show mathematics to youngsters and teenagers, and you said everybody is amazed, but in fact. You took the idea that when you want to communicate science and mathematics to people, you can use bubbles, and they will be amazed, and then you can explain mathematics. But I like to push this a little bit further by saying that at the beginning, why do we have these theories about bubbles? Well, how do we know it? Because we observed bubbles at the beginning. So here is a picture I took at the beach, and when you have a certain amount of proteins in the water, like from algae and stuff like that, there's bubbles forming, and if two bubbles touch or more bubbles touch, it makes a foam. And then we can analyze the structure of this foam, and there are mathematical theories which evolve, very beautiful theories, and then you can go back and explain people. So this is really beautiful cycle to explaining these ideas. Hugo and Bruno, they knew that I would bring this up. What I wanted to show here is that you see two cracks in the street, and one crack comes from one direction and the other one's from the other one. So these are local phenomena, two different things. There's no pattern, no shape, no structure. But then when these two independent structures come together, they will influence each other. And they will influence each other in a way that when you understand what cracks are, cracks will form to release tension. Okay? So when two cracks come, so you have one crack, another one comes. So this crack will release tension in one direction. So to maximize the release of tension, the other one will meet the first one in an angle of 90 degrees. Okay, so now if we have two cracks coming together, they will tend to meet at angle of 90 degrees and turn around each other to meet again. So, and this is a structure emerging because you have two different local physical laws ruling some process. But I mean that patterns and beauty and structure emerges when these independent physical processes merge together and influence each other. So pattern, I think, should be pattern and beauty and structure creating should be thought not only in space, a pattern in space, but it's always the result of a dynamical process, of a process which brings local things together. It's also always something global. Otherwise, you won't have a pattern emerging. So we should think of it not as a pattern in space, but a pattern in space-time, perhaps. And this will open up very interesting directions, I think. So, and not only we as scientists are amazed by this, so we probably underestimate a lot of times the beauty in something which gets destroyed, of destruction. There's a really beauty in destruction and in things falling apart. And there are artists taking this up. I had another picture here with the two vases by a Japanese artist, and they already hundreds of years ago or thousands of years ago, they used these cracks as a decorative element. So independently of science, but these patterns, these cracks, they represent some kind of beauty to a lot of people coming from a lot of directions. And this is a really wonderful image of Alberto Burri, which was a few years ago at the Centre Pompidou in Paris, and it's 5 to 2 meters, and it's cracks. So it's really impressive if you stand before it. And then you see this pattern emerging by cracks building up and forming this pattern in time. Yeah, so next time you see a dry soil, you won't see that with the same eyes again. So to end with, I wanted to focus a little bit more on this, on what I said about patterns or structure being a process in time. And you have this also in living things. So you have coevolution of different species, which really adapt exactly to each other to be able to survive. And this is a pattern or a structure which is really formed during probably millions of years. And there's an orchid which hides its nectar and its pollen really down here. And you need this moth or this insect with the really long trunk to be able to get to the nectar and take the pollen to go away. So this is also this co-evolution of needs also creates very nice structures which are very beautiful, I think. So nature really produces these beautiful things. And this may be in what you said in minerals or in materials and how they interact with other materials. Like I find when you have light, which is something very pure, which has some properties which are interesting and comes to a crystal and then it doubles the period. I find this, knowing this and knowing that there is this non-symmetry can be very beautiful. So great. So that's what I wanted to say now. Let's see where the discussion will lead us. This is a picture of an animal at home who doesn't understand how this is possible, in fact, and how it can fit, in fact. Okay, thank you very much. Yeah, that's what I wanted to say.